Bismillahirrahmanirrahim. Assalamu alaikum, student.
وعليكم السلام ورحمة الله.
So last time we have finished this chapter number 4, and today we will solve two problems of this chapter about uniform circular motion, and then we will start this chapter number 5. So let's see first the two problems of this chapter number 4. So in this problem, a car travels in an oval path. Oval path means it's the radius is not equal. Okay, so this here the value is 400 meter, but this is 500 meter. So that's why it is an oval path or elliptical path. As shown in the figure, VA is 25 meter west. This is VA, okay, in the west direction, and VB is 20 meter in the north direction. So this is VB at this position, 20 meter. The ratio of the magnitude of the centripetal acceleration at B to that at A. So we have to find this value. To find this value, what we will do? So first we will see AA for AA. At A point, the acceleration. So it will be VA square over RA. You know that centripetal acceleration is VA square over RA. And also AB is equal to what? VB square over RB. So we want to make this ratio. So ratio is AB over AA, and this is equal to VB square over RB divided by VA square over RA. And this is equal to VB over VA whole square. We can write it like this one. And then RA over RB. So we can write in this style. So after writing this one, then you can put the value of VB and VA. So VB value is 20 meter divided by VA is 25 and whole square. Multiply RA is 400 and divided by 500. So in this way you can solve it. This is cancelled, and also you can solve this by cutting 5 4s are 20 and 5 5s are 25. So this is 4 over 5 square multiplied by 4 over 5. So it means it is 4 over 5 cube. So it is 4 multiplied by 4 multiplied by 4. This is 64. And 5 multiplied by 5 multiplied by 5 is 125. So when you solve this one, the answer will be 0.512. This is the ratio. So here is the answer. This one. Okay. After this, see this problem. So in this problem, in the figure, the total acceleration of the particle moving clockwise in a circle of radius 2.5 meter at a certain instant of time has been shown. So here the particle is moving in the clockwise direction. This is the direction of clockwise. This is clockwise direction. So the total acceleration is given. A is equal to 15 meter per second square. And radius is given. This is radius 2.5 meter. At a certain instant of time has been shown. At this instant, find the radial acceleration. So to find the radial acceleration or the tangential acceleration, what we have to do, because the total acceleration is given. You know that total acceleration is what? Total acceleration is actually the radial acceleration square plus the tangential acceleration square. And this is the under root. This is the tangential. I'm writing a tangential, not a total. Total is this one. So from this formula, we cannot find this, but here he has given this figure, and from this figure, we can find the components of this vector, which is making an angle of 30 degree. This is 30 degree. So what you will do, you will find the component, one component here and one component is here. So this component is along the tangential velocity or the speed. So it means this component is AT, tangential acceleration component. So this is equal to, AT is equal to what? So AT is equal to A sine of 30. So A is 15 into sine of 30 is 0.5 or 1 over 2. So this is 7.5 meter per second square. Now you want to find the AR. So AR is this line. This is your AR line. AR is equal to A cos of 30. So A is 15 and cos 30 is 0.866. So when you multiply and solve it, it will be 12.99 meter per second square. Now you have AR and AT. Now you can find the speed of the particle. So speed is AR is equal to V square over R. So V square is equal to AR multiplied by R. So V is equal to AR multiplied by R and under root. And AR is what? 12.99 multiplied 2.5, it is given here. So under root. So when you solve this one, you will get the value around 5.69 meter per second. So this is the problem. And in this problem, the problem is to find the components of a vector. So the component of vector mean you will find the component of acceleration. One component is this one and one component is this one. And this component is parallel to this one. So it means this is tangential acceleration direction. And you know that tangential acceleration direction is always parallel to the tangential velocity direction. So in this way, you can solve this problem. Okay. After these two problems, now I'm moving towards chapter number 5. So for chapter number 5, first I share the open board. Now you can see the open board. So in chapter number 5, what we will discuss? We will discuss the laws of motion. The laws of motion. So here we will discuss Newton's first, second, and third law of motion. Also, we will discuss the concept of force, the mass, the weight, the gravitational force, and then we have some application part of Newton's laws of motion. So remember that laws of motion totally depends on force. It totally depends on force. So first we will see the concept of force. Force concept is what? Force concept is this one. If you have a body here and you are applying some and push it in this way, this is external, okay? And the body state is changing. Here its velocity is u, then it's v. So its state is changing. Who is changing? This thing, and this thing is called force. So force is an external agent. It is an external agent. It is not internal. It is an external agent which changes the state of an object. The state first is here, the second is here. So forces, remember that forces produce acceleration. Forces always produce acceleration because we know that force and acceleration has some relation. You cannot say that force produce motion. No, force produce acceleration. Acceleration means change in velocity. And the unit of force is Newton. You know that this one. The unit of force is Newton. But here I want to discuss with you the types of the forces. the types of the forces. I write in the next slide. So types of forces mean what? Types of forces. So in types of forces, we have some non-contact forces. Non-contact forces. Non-contact forces mean they have no contact, but they exerting force. And what are the non-contact force? Like gravitational force. Gravitational force is non-contact force. Electrostatic force. So electrostatic force is between the two charges. They are exerting the force without touching. And magnetic force. This is also without touching. So remember, gravitational force is attractive force. And we will discuss in maybe next chapter or in this chapter a little bit. Electrostatic and magnetic force you will study in physics 104. So electrostatic force is between the charges. It is attractive and repulsive, both. But gravitational force is always attractive. And magnetic force is between north and south poles. So it is attractive and repulsive. Both these forces are almost same, but their difference is this one. You cannot separate the north pole. You cannot separate the south pole, but you can separate the charges. Positive charges you can separate. Negative charges you can separate, but you cannot separate the north pole and the south pole. This is the difference. But gravitational force is always attractive. It is not repulsive. So these types of forces are called non-contact forces. Then we have another types of forces, that is contact forces. So in contact forces, we will study in this chapter the tension force and normal reaction force. And then in the next chapter, we will study the spring force and then frictional force. So all these forces are called contact forces, and we will study in this chapter these types of forces. Okay, other forces are nuclear forces. Nuclear. So nuclear forces mean if you have a nucleus in an atom, you know that there is a nucleus. So nucleus has proton and neutron. Neutrons are neutral, but many protons exist in the nucleus. So between proton and proton, there is a force that is called nuclear force. And the last force, that is called weak force. So weak force we normally discuss in chemistry like van der Waals forces. So van der Waals forces we discuss in chemistry between the molecules in liquids. So our target is only the contact forces in this chapter. And we want to discuss this, and especially these types of forces. Okay. After this, the first law of motion. First law of motion. So first law of motion, Newton's gave these laws in before 1900, in 1800. And still these laws are famous and valid, and no challenge on these laws, no challenge. So first law of motion is actually about the force. Before I have already explained that all laws of motions are about the forces. So it is about the force, but what kind of forces? This is a qualitative, only the qualitative analysis of force. Analysis of force. It will not give you the quantity of the force, qualitative analysis. So first law is this one, if F of net force is 0, then net acceleration is 0. This is called first law. So here the concept is the net force. So net force means Many forces are acting on the body and their sum is equal to 0. This is called net force. Or you can understand, if this is a body and this is the applied force you are applying and the frictional force in this way, then we will find the net force. F minus F is equal to net force. So this is called net force. We always measure the net force. We are not measuring the force. We always measure the net force. So the acceleration will be the net acceleration. So it means if F is equal to 0, no change in the state. No change in the state means the body is not moving. So what he said in the first law, he said that if a body is at rest, mean net force is 0, is at rest, it will remain at rest. It will remain at rest. One thing. The second thing, he said if a body is in motion, a body in motion will remain in motion. Will remain in motion. Unless, this is the condition, unless no unbalanced force. No unbalanced force means no external force acts on it. So if a body is in motion, it will remain in motion. So you can see that if this is a ball, if you throw the ball on the road, on the surface, he is saying it will continue to move, but due to air resistance or due to this frictional force, it will stop. If we remove this frictional force and this air resistance, then it will continue to move. So this is called Newton's first law of motion. So remember, if net force is equal to 0, also we call it body is in equilibrium. But we will see later, there are many other kinds of equilibrium in this. But here, if net force is 0, the body is also in equilibrium. One thing. The second thing, in this chapter, that is law of inertia. So first law is also called law of inertia. So law of inertia mean what? Law of inertia mean actually it depends on the inertia. So inertia mean what? First, inertia mean the tendency of an object to resist any attempt to change its velocity. You can understand that if this is a block and you are applying the force, and the block is not moving. It is not moving due to its inertia. Bigger the mass, more inertia. So it means inertia is totally depends on the mass. You cannot find inertia separately. You can find the inertia with mass. So this first law is also called law of inertia. Remember this one. Just remember this one. Okay. So here you have seen that in the first law, what we are saying, that in the absence of the force, we are talking about the absence of force. Absence of force means the net force is equal to 0. This is the absence of force. But in the second law, we will see in the presence of the force by applying the force. Okay. So this is all about the first law of motion. But the most important quantity here I have discussed, this is mass. What is mass? Mass in chemistry, we define that it is a quantity of matter. Quantity of matter. Quantity of matter is called mass and its unit is kilogram. But this quantity of this property is mass is that property of an object that specifies how much resistance an object exhibited. Mean, so mass is actually the inertia. So if you have this block and you apply the force, so initially you can see that this block will oppose and motion opposite to this applied force. And this is due to the inertia or due to the mass. So if you have a bigger mass, bigger inertia, and you apply a more force. So in the previous classes, you have studied this equation that F is equal to ma. So from this equation, you can understand that if this is a body and this is m1 and you are applying F1 force and acceleration is a1, you can write that F1 is equal to m1 into a1. But we have the same, we have the second mass and second acceleration, and the force is the same. F1 is equal to, this is F1 and F1 are equal. So if they are equal, then this equation will be equal to this one. So you can write M1 A1 is equal to M2 A2. So here M1 over M2 is equal to A2 over A1. So you can write this equation in this style. So here you can understand that A is equal to F over M. Bigger mass, less acceleration. Less mass, more acceleration. If force is constant. The condition is this one, that F is constant. So if F is constant, then acceleration is proportional to mass. And this is what we call second law of motion. So you should remember this one. And mass is that quantity which always remains constant, always remains constant. And when we write this equation, F is equal to ma, then we normally put here I, and this is for inertial mass. This is called inertial mass. So inertial mass mean that we are discussing in the inertial frame of reference. Inertial frame of reference mean what? In which the Newton's laws of motions are valid, and non-inertial are those in which Newton's laws of motions are not valid. So that's why it is called inertial mass. But when we apply this equation mg, then we write here g. This is called gravitational mass because this mass is under gravity. But this mass is not considered under gravity. It is moving. If the body is moving like this one, then inertial mass. If the body is falling, then gravitational mass. So this is all about this first law and about the mass. Now I'm moving towards the second law of motion. So see the second law of motion. So this is related with second law of motion. Second law of motion. Actually, the Newton don't say that F is equal to ma. This is Newton's second law. No, this is the equation to find the acceleration. This is the equation to find the force. But Newton said that force is equal to delta P over delta T. And this is called rate of change of momentum. We will study in the next chapter. And this is what Newton said at that time. And this is actually this is called Newton's second law. This is not Newton's second law. This is F is equal to ma to find the force or the acceleration. But here he has put, because we can derive this equation from here. So that's why we normally said that this is Newton's second law. Anyhow, so what is Newton's second law? Second law is this one: acceleration is inversely proportional to mass. We have seen in the previous slide. And acceleration is proportional to mass. More force, more acceleration. When you combine these equations, it is a F over m, like this one. And you can write A is equal to constant. Here you will write here some constant and multiply by F over m. Constant is here 1 and A is equal to F over m. So this is called Newton's second law. Okay. So here the equation is actually A net is equal to F net. Net force concept is important, not force concept is important. Like this one. So you can write in this vector form. So here net force, again I am writing that net force is equal to F1 plus F2 plus F3 plus so on. So this is called net force, okay? Sum of forces. So normally we define it like in the sigma notation. This sigma mean, here sigma mean F1 plus F2 plus F3, like this one. This is the proper definition of sigma. This is called sigma. And sigma means summation. But you can apply sigma if this force value is integers. Integers mean 1, 2, 3, 4, like this one. But if the numbers are in 1.2, 1.3, 1.4, and these numbers are called continuous number. These are called continuous number. And these are whole numbers, integers. Okay. If numbers are whole, value is whole, apply sigma. If value is continuous, apply integral sign. This is integral sign. You have studied maybe in your mathematics course. So sigma f of x is equal to ma of x. Sigma f of y is equal to ma of y. Mean that sum of x component of force is equal to ma of x. Sum of x component of y force is equal to ma of y. So this is all about second law. These are the normal things which you have already studied, but maybe here I have given you some more information. So after Newton's second law, there is one definition, that is the gravitational force and the weight. I have already explained this one. The gravitational force mean this is the G is equal to F over M. Okay. So you know that G value is 9.8 on the surface of the earth, on the surface of the earth. Okay. So G is actually the ratio between the force and the mass. So force is what you can write. This is W over M. So this ratio must be constant, mean that if you increase the weight 2 times, the mass will increase 2 times. So ratio will be constant. This ratio is like pi. You know that pi is what? Pi is 3.1417. But this pi definition is this one. The circumference of the circle divided by the diameter of the circle. Diameter of circle, of that circle. So the ratio must be constant here. Same, the ratio must be constant here. So if you increase the weight 4 times, it means you are increasing the mass 4 times. The ratio is constant. So that's why G is constant. Okay, after this, now I want to discuss with you the third law of motion. Third law of motion. So in third law of motion, which is very famous and looking very easy, but it is not too easy. So here you are defining the third law, that action and reactions are equal but opposite in direction. Opposite in direction. So opposite in direction. So this is very simple definition, but it is not a simple. It is a little tedious. Tedious in what sense? The first point, this statement is telling us that action, reaction, pair exist. Pair exist. So pair mean if one is action, the other is reaction. So you can say that if this is, I'm writing is action and this is reaction. You know that the pair, ordered pair, you can write like this one, 2, 3. So this is like 2, 3, action and reaction. Okay, number one. But the second thing is very important. that these action and reaction, these pairs, surely these pairs are forces. These pairs must be of same nature. Same nature. Same nature mean if this is F, this is minus F. I will give you the one example. Okay. So let's explain these 2 points. First is, if a body is placed on this table, suppose this is a table and a body is placed on it, its weight is always vertically downward. And this weight is due to this earth. Here is the earth. Okay. If this body is placed on table, the table will apply a force normal on the upward direction. So here you can normally in the previous classes, maybe we are seeing that action and reaction exist here, and Newton, this is the example of Newton's third law. But this is not an example of Newton's third law, because in the second this line, you understand that these pairs must be of same nature. So same nature mean if this is N, but here it is mg. But same nature mean if this is N, it should be N. If this is mg, it must be mg. Minus. Okay. But here, if it is upward positive and minus mg downward, but this is not same nature. Not same nature. Same nature. So that's why we cannot say that they are action and reaction pairs. But due to this table, you can say that if it is exerting a force on the table and the table is exerting force in the upward reaction, so the action of the table due to this block on the table is this one, not mg. So this is N, block on table. This is table on block. So you can write that block on table minus N table on block. Now this is action and reaction pair. And here Newton's third law is applicable. Otherwise, it is not applicable. So this is very important. And in this chapter, we will study the forces, how to find the forces. So here is one body, its mg is downward, its normal reaction is upward. We will discuss like this one. If a body, you apply the force here and the frictional force in this way, we will use these concepts to solve our problems. And the most important thing, the inclined plane, the body is here. It's making an angle theta, and this is mg, and this is r new and normal reaction. We will solve the problems of like this one. The body is moving up, or the body is moving down, or the force is applying like this one, or the force is applying like this one. So then you will see how we can make the components and to solve the problems. Then we will see that the body is hanging. The weight is vertically downward and this tension is upward. Okay. And if we attach more weight, then what will be the tension? So we will apply the same concept of net force T minus mg is equal to net force. So all these problems we will solve, and but first we will discuss the articles of this chapter, and then we will solve the problems. Okay, if you have any question, you can ask me. Otherwise, see you in the next lecture. So if you don't have any question, inshallah, see you in the next lecture. Okay. Assalamu alaikum.
Thank you, Doctor.
Assalamu alaikum.